Yeah, I can. I understand how everyone would be tired because it's coming towards that time period where like exams and finals are coming up, right? But yeah, I mean, it is what it is, you know, like you go through these things as a student. I've told you the story of how like I would schedule like what times I would cry, right? So I don't know. Life is a sine curve. Anyways, so um, before we start today, we have a couple of announcements. Are we going to go through all the questions on the review sheet? Yeah, we'll go through all of it. There was only 6 questions, so I'm pretty sure we can go through all of it. Anyways, so announcements. Number one, if you've been a hunter for like at least a semester, then you know that there's like teacher evaluation. So I don't think they send you an email this semester, did they? About teacher evaluations? I don't know. I'm not a student anymore. Oh, they did. Okay. Yeah. So if you didn't do those, then you can go ahead and do those. Um, they're not mandatory or anything. So, like, I know some people can't get it to work, but that's okay. So if you can't get it to work, then just do it. I think they do it for like data collection purposes. So yeah. Second announcement is there is tutoring for finals week at the Dosiani Math Center. So by a show of hands, actually no, not by a show of hands. Type in the chat if you have used the Math Center this semester. I guess just type yes if you have. The Dosiani Math Learning Center, the place where they offer math tutoring. No. Okay, well, I emailed them, but they never replied. Oh, that's what's going on with their customer service? Anyways, so they emailed me asking me to announce this to the class, but they're offering tutoring for finals week. So let me just pull up their website real quick. Here you go. So this is their website. Most of you probably have seen it before. But on this website, if you just scroll down a little bit, you'll see they added this new link here. It says finals week tutoring hours starting December 10th. So they are using Zoom for finals week. So I'm assuming you just go in and there's going to be a tutor inside the Zoom call that can help you. So let me see what happens. You click here. What class are we? We are Calc 2, right? Yes. So that's 155. So here is the times where tutoring is available during finals week. So you guys can go look this up in your time. I'll probably send out an email just to give you guys the link. But I would suggest you guys take advantage of it, right? Because my office hours can only be so long. So when you need extra help, this is one of the resources that you guys can use. Hopefully they'll reply to your email, because that's not a good sign if they never replied. But it doesn't look like you need to email them for finals. So you can just go into the Zoom call. Let me see if I click a link. Okay, yeah, you could just join, it looks like. So yeah, there's that. Yeah, that's all the announcements we have for today. So I believe we are going to go over the review sheet. Did you guys get a chance to do the questions on it? Do one question. Okay. Well, for those of you who did do some of the questions, just help me out here because I didn't really do all of them. I just like scanned through all of it and just thought about like what's reasonable. So um, we should still be able to get through all of it though. So let me just pull it up. The final is cumulative. So it has stuff from exam 1, 2, and 3. But yeah, the format's the same. Yeah. It's just the topics are not just like the last few topics. The final covers everything. Yeah, we can just go in order. Okay, so here is the review sheet. Will we join the Zoom call for the final? Yeah, definitely. So just like all the other exams, you should join the Zoom call for the final, just in case, you know, like if anything comes up and you want to ask a question, I can reply right away. Do we get the same time as usual for the final exam? You get 2 hours for the final exam. So yeah, pretty much, I think. Yeah. All right, who's third exam is December 8th. Okay, so let's do the review sheet now. So this is the first question. This one says, determine whether the following series converges or diverges. Okay, so just like exam number 2, one of the issues with taking Cap 2 exams is that the directions don't really specify which direction to go, right? So it says determine whether it converges or diverges. That can lead you in a lot of different directions, right? We learned so many tests and so many ways to tell whether something converges or diverges. So one of the skills you need to know is to recognize which test you need to use by the form of the given series. So taking a look at this one, which test would you use and why? Alternating. Yeah, so alternating series test. And then really quickly, can one of you just explain why? The -1 thingy. Yeah, very good. So the -1 to the n plus 3, what that does is it makes each term in this series alternate signs. Hence, this is an alternating series. So because of that, it's good to try the alternating series test. Now, also do make sure that you memorize all the details of each test. For example, the alternating series test. That was one of the tests where if it fails, you cannot conclude anything, right? So the alternating series test was one where, like, if it fails, then you cannot say it diverges. You have to go do another test. But hopefully it'll work for this one. So let's try it. So for the test, we need to identify B of n. So let's do that. The B of n is basically everything except for the alternating part. So for this one, it's square root of n over n plus 4, right? And we need to check 2 conditions for the test. So the first condition was that B of n has to be decreasing. And then the second condition is that B of n, the limit of B of n has to go to 0, right? So I guess let's check that one first. So limit of square root of n over n plus 4 as n goes to infinity. Does this equal 0? What do you guys think? I think it should, right? Let's see. How can we prove it though? So you can divide by the highest power of n. So that will give you square root of n over n over n plus 4 over n. So this goes to 1. This right here is equal to 1 over square root of n. Okay, so what we have is 1 over n, and then we have 1 over square root of n over 1 plus 4 over n. Okay, so as n goes to infinity, then 4 over n goes to 0. And then this part right here also goes to 0. So what we have is 0 over 1. Yeah, so this is 0. Okay, so that's fine. The limit does go to 0, so one of the conditions is satisfied. Now we need to see whether it's decreasing. So is b of n a decreasing sequence? We have to show that work on the exam. Yeah, you would, because I guess it depends if it's obvious or not. So for this one, it's not that obvious, which is why I showed work. But for something like, if you're trying to show that the limit of 1 over n, like if you're trying to show something like this, I wouldn't say it's necessary. But for something that's not as obvious, I do want to see the work, okay? Or you can just show the work for whatever. Just to be safe, you can just show the work. All right, so is it decreasing? I don't know, let's see. Let's list out some of the terms of this sequence. So when n equals, I guess we can make a little chart here, and then b of n. So when n equals 0, then b of n is 0. When n is 1, then b of n is square root of 1 over 1 plus 4. That's 1/5. Okay, well, it didn't decrease there, but that doesn't mean that the test failed yet. So one of the details of the test said that it only has to eventually decrease, right? It can increase in the beginning, but if it decreases later on, then it's also fine. So 2, this is square root of 2 over 6. I'm not even sure how these compare. Okay, so the best way to show that it's going to decrease is just take the derivative and show that the derivative is negative. So because just listing out the terms is not obvious here, you should probably take the derivative. So let's go ahead and do that. Derivative. So the derivative of b of n is the bottom times the derivative of the top minus the top times the derivative of the bottom. That's just 1 all over n plus 4 squared. Okay, so that's the derivative. And let's just simplify a little bit. So this is n plus 4, 1 over 2 square root of n minus square root of n over n plus 4. Okay. All right, so let's think about how we can show that the derivative is eventually negative. So if the derivative is eventually negative, then that shows that b of n is eventually going to decrease. So let's think about this. Here's the derivative. Can you guys see how the denominator of the derivative is always going to be positive? Yeah, because it's squared. And when you square anything, then it turns positive. So the denominator is always positive. So if we can show that the numerator is eventually negative, then that also achieves our goal, right? So we have n plus 4 times 1 over 2 square root of n minus square root of n. So is the numerator going to eventually be positive? That's the question. Let's see. Sorry, is the numerator going to be eventually negative? So if you, So if I plug in, say, n equals 4, I'm going to get 8 times 1 over 2 times 2 minus square root of 4. So this is going to be 8 over 4 is 1/2. Oh, that's 2 minus 2. Okay, so that's 0. So then if you type in, or if you plug in n equals, I don't know, like, let's try 9, because that's a perfect square root. So that's 13, 1 over 2 times 3 minus 3. So that's 13 over 6 minus 3. Yeah, that's negative. Okay. Yeah, okay. So I guess this is fine. What's really going on is that as n gets larger, then this term gets larger faster than this term, which I would accept that as an argument. So yeah, I would say that the derivative is eventually decreasing here. Yeah, I mean, if you want, you could plug in like more n's, like n equals 16 or whatever, but I think this is fine. So by observation of the derivative, we see that the derivative is eventually going to be negative, and then that means that b of n is eventually decreasing. So that's the second condition satisfied, okay? So we can say that this converges, right? Yeah, 1 second. Okay. Yeah, so for this question, we use the alternating series test. The alternating series tests say a series will converge if it satisfies 2 conditions. So the first condition is that the limit of b of n has to be, limit of b of n as n approaches infinity has to be 0, which we showed here. And then the second condition is that b of n has to eventually decrease. So we're trying to show that this part has to eventually decrease, which wasn't obvious when we just listed out each term for b of n. So what we did was we took the derivative instead. And then once we take the derivative, which was this is the derivative of b of n, we showed that the derivative eventually was negative. So over here, we plugged in values into the derivative. So plugging in 4, and then we plugged in 9. When we plugged in 9, that made the derivative negative. And then based on this, we can also conclude that plugging in bigger values of n also make the derivative negative. So if the derivative is eventually negative, then b of n eventually decreases. So that's the second condition satisfied. Is that okay? So it's just based off b of n. Yeah, yeah. The alternating series basically wants you to show stuff with b of n. Alternating series test. Just keep in mind, like, depending on what test you choose to use, you might have to do different things. But yeah. Let me see if I could find the alternating series test formula. Okay, so here's the alternating series test in case you guys need it for reference. Notice how if you have alternating series, which is -1 times b of n, then you just do stuff with b of n. Okay, and then based on your result, then you can say the series itself is convergent. Okay, let's move on to the next question. Question number 2, this one. So this one, again, directions say the same thing. Determine whether it's convergent or divergent. Really no other clues here on what to do, but just based on the series, what do you guys think? So ratio test, any other suggestions? Ratio, okay, why do you guys say ratio? So you guys are correct. It would be a ratio test, but it's important to know why. No specific reason for the factorial. Yeah, so the factorial does give it away. Factorial usually mean ratio test. But also because there's an e to the 4n, right? So whenever you have like exponents and stuff, ratio test is also a good thing to try. But yeah, very good. So let's try the ratio test. Remember that for the ratio test, we need to take the ratio of the next term over the current term, right? So the next term, which we denote with a of n plus 1, over the current term, which is a of n. So this would be e to the 4th of n plus 1 over n plus 1 minus 2 factorial. So that's a of n plus 1. We're going to divide that by a of n, so that's multiplying by the reciprocal, n minus 2 factorial, e to the 4n. Would you use any other test if there was a factorial? Yeah, no, I don't really think so. I think ratio test is probably the only one you can do with factorial things. So let's try to simplify this. This is e to the 4n plus 4 over n minus 1 factorial times n minus 2 factorial over e to the 4n. Okay. So e to the 4n plus 4, that cancels out with e to the 4n to leave you with e to the 4th, right? And then now let's look at n minus 2 factorial and n minus 1 factorial. What does that simplify to? N minus 2. I think that's right. Let me double check that. So if I write out n minus 2 factorial, that's basically n minus 2 times n minus 2, so minus 3, n minus 4, Yeah, n minus 5, and so on, right? So that's n minus 2 factorial. And then the denominator, we have n minus 1 factorial. So that's n minus 1 times the next integer down, times the next integer down, times the next one, and so on, right? Okay, so what cancels out here? Basically all of these, right? So we're left with n minus 1 in the denominator. Okay, so we have n minus 1. Wouldn't n minus 2 factorial be n minus... No, factorial goes down. It doesn't go up. So 4 factorial is 4 times 3 times 2 times 1. Yeah. Okay, so that's the simplified version. And then the ratio test also said we have to take the absolute value, which, you know, I don't think it makes a difference in this question, but let's write it anyways. N minus 1. After that, we have to take the limit of whatever we get. So once we take the limit, well, we can factor out the e to the 4th because that doesn't depend on n, that's just a constant. So we have limit n approaches infinity of 1 over n plus n minus 1. So what's the limit here? Zero, yes. So 0 times e to the 4th is 0. Okay, so we got our limit. Do you guys remember what's the conclusion for the ratio test? So yeah, the ratio test said that once you get your limit, if it's less than 1, then it's absolutely convergent and therefore convergent. And if it's greater than 1, it's divergent. And if it's equal to 1, then it's inconclusive. So for this case, we have convergent, right? This is convergent. Okay, good. So you guys can, you know, sort of tell where this is, like the general strategy for these problems. So half the battle is really choosing the right test. And then once you have the right test decided, then, you know, just don't mess up on your simplification. So yeah, so be careful with the factorials. My advice would just be to write it out if you have to, because that will help you see clearly what cancels out, right? It's a bit confusing when you have like n minus 2 factorial because it's like it's negative. So yeah, so just make sure you're going down by 1 when you write it out. Anyways, I hope that's okay. Let's go on to the next question. So question 3 says, determine the interval and radius of convergence for the following power series. Okay. This one shouldn't be too bad because we only have two ways of doing that. Do you guys remember what are the two ways of how we do these questions? So root test was one of the ways. What's the other way that these questions use? So root test was one of them. What's the other one? There was another test that applied to these questions. Yeah, ratio. So whenever a question says determine the radius of convergence for a following power series, you either do ratio test or root test. It's always one or the other. I would say is one more common than the other? I don't know, but there's ways to tell whether like which one's appropriate. So for this one, which one do you guys think it is, and why? Root. Yeah, I think I can see that. Because of the variable and in the exponents. So it's not actually just that. There's another reason why root test is more appropriate here, because you can have a variable and in the exponent, but it can still be a ratio test. But there's something else about this series that makes it a root test. The n goes away after you root it. Yeah. Yeah. So that's really what I was getting at. The fact that there's an n in the exponent for both the numerator and the denominator. So that's really why it's better to use a root test for this question. Honestly, you could probably still do the ratio test, but the root test would just be a lot easier. So let's do the root test. So the root test says, instead of taking the ratio like you would do in a ratio test, you would take the nth root. So we have this as our expression. We're going to take the, first take the absolute value and then take the nth root. So what this does is it just divides all the exponents by n. So you get absolute value of x squared over absolute value of -3. Okay, and then this becomes, well, x squared is always positive, so the absolute value doesn't do anything. And then -3 with the absolute value makes it +3. Okay, so this is, yeah, that's fine. Okay, so next we have to do the same thing as the ratio test. So to take the limit as wait, was it n? Yeah, it was n, right? That's n goes to infinity of x squared over 3. So we can factor out the, actually we can factor out the whole thing because there's no n in there. So it's just this limit as n approaching infinity of 1, I guess. Okay. So limit of 1 is 1, right? So we just have x squared over 3. Okay, now what? Do you guys remember the next step? Oh, we already took the limit. So the limit of 1 as n approaches infinity is 1. So it's just 1 times x squared over 3. So this is our limit for the ratio test. What do we do next? So remember that we're trying to find where this series converges, right? So based on the ratio test, how do we know whether a series converges? Or ratio root test. Well, they have the same. Yeah, they have the same thing. So yeah, the ratio and root tests say a series will only converge if your limit is less than 1. So here's our limits. We have to solve the inequality of less than 1 in order to figure out where it converges. What's with that face? So we have x squared is less than 1/3. And then taking the square root, we have x, absolute value of x is less than square root of 1/3. And then if we were to solve this inequality, we would get basically, well, we don't know whether it's brackets or parentheses, but negative square root of 1/3 and positives square root of 1/3, right? So that would give you this interval of convergence, which means any x value in between these two numbers will make our power series converge. The question is, do we include the endpoints? 3 now. Oh yeah, sorry. I divided instead of multiplied, my bad. This should be 3. So negative square root of 3 and positive square root of 3. So we need to test the endpoints now. And then to test the endpoints, that will tell us whether or not we use brackets or parentheses. So does the series converge at x equals negative square root of 3? I don't know, let's see. So this is our series. And then let's test x equals negative square root of 3. So that will give us the following series. We will have negative 3 to the 2n over negative 3 to the n. This will give us negative 3 squared. Okay, does this series converge or diverge? That's just 9, right? What do you guys think? Summation of just 9, does that converge or diverge? Oh wait, did I? Oh, my bad. I made another mistake. I plugged it in wrong. It's square root of 3. How far? Let's go back. So this is incorrect. Yeah, like, I swear, like I make too many mistakes on this. So it's negative square root of 3 to the 2n. Okay, well, you can think of that as negative square root of 3 squared to the n, right? Or negative 3 to the n, which would make it, so negative square root of 3 squared is 3 to the n over negative 3 to the n. Okay, I think that simplifies a little better actually. So this is just negative 1 to the n. Okay, negative 1 to the n, does that converge or diverge? So this is just the series negative 1 plus 1 minus 1 plus 1. Yeah, that definitely diverges. That one's kind of obvious, so you don't need to say why. But if you want to, you can just say, divergence test, so that diverges. Okay, so that diverges gives this side of the interval a parentheses. And then now let's test positive square root of 3. So let's delete that. So test positive square root of 3. So that gives you series square root of 3 to the 2n, negative 3 to the n. This gives you 3 to the n over, is it just the same thing again? I guess. Okay. Yeah, I guess it became the same because when you square negative square root of 3 or positive square root of 3, it's the same thing. So this is the same series as the other endpoint. So this also diverges. Okay, so our interval of convergence is negative square root of 3 to positive square root of 3, not including the endpoints. Then they also want the radius of convergence, right? So the radius of convergence would be square root of 3. This is the interval. This is the radius. All right. Why do you take the absolute value of x after you square both sides? Over here. I took the square root of both sides. When you take the square root of both sides, you have to have a plus or minus. Yeah. Okay. Next question. All right, question number 4. So this one says, write the following function as a power series and give the interval of convergence. Simplify your answer to only have x appear once. Okay, so we have f of x is equal to 2x squared over 2 plus x to the third. We want to write that as a power series. So thinking back to all those things that we have learned, what was one of the techniques that we learned that can help us here? You guys remember? Do you guys remember this? Divide by 2 over 2. I guess you could do that. Sure, we'll take your suggestion. So we can rewrite f of x as x squared over 1 plus x to the third over 2. So I just divided the numerator and denominator by 2. Yeah, that's fine. We could do that. But we also want to use this fact on the right hand, on the right side of the screen here. So if we have a function in the form 1 over 1 minus something, then we can use this formula to write it as a power series. So let's try and see if we can get our function in that form. First thing I'll do is I'll factor out the x squared just to make the numerator a 1. So I'll have f of x is equal to x squared over 1 over 1 plus x to the third over 2. All right, so we're a little closer now. We have a 1 here, we have a 1 over there, but we need a minus sign, right? Because the formula says we need to use a minus sign. So what I will do is I'll just, instead of writing plus, I'll write 2 negatives. So f of x is x squared over 1 minus a negative x squared over 2. Okay, so now it's in the form that we want, which means we can write it as a power series. Yeah, what's up? Oh, yeah, thank you. Yeah, as you do this more and more, I think you start to lose yourself. Like you can't really do math anymore. Yeah, sorry, it's cubed, x cubed over 2. Like I swear, someone asked me the other day, like, what's 1 minus 2? I'm like, how would I know? Anyways, so it's in the form now. Now we can use the formula. So this function can also be rewritten as x squared times, oh, is that what you're asking? The 2's? Yeah. So the first thing that a student suggested was we just divide the numerator and the denominator by 2, which you're allowed to do. So I went ahead and do that. Shouldn't we have it on the side? Well, what we did was we factored it from the numerator and the denominator. So they essentially just cancel out. So they go away. Yeah, if you only factor it from like the top, then, or just the bottom, then, you know, it would stay there, but okay. This is the power series, negative x to the third over 2 to the n, right? N equals 0 to infinity. So this relationship will only hold provided absolute value of negative x to the third over 2 is less than 1. Okay. So make sure you know how to do this substitution, right? Getting it in the proper form and then writing it as a power series. Okay. The question wants the interval of convergence, and we can find out the interval by solving this inequality. So we have absolute value of x to the third is just x to the third. And then this is going to be less than 2. All right, I was going to write 1/2 again. So this is 2. There's the x squared outside the summation. Yeah, that's fine. We'll deal with that later. Right now, we're just doing the interval of convergence. I take the cube root of both sides. So this is x is less than the cube root of 2. What's the cube root of 2? I don't know, it's some decimal number. But our interval is negative cube root of 2, comma, positive cube root of 2. Also remember that you don't actually need to test the endpoints here, because for this particular formula, this is strictly a less than sign, right? This is not a less than or equal to. So because it's strictly a less than, then that means that the endpoints will definitely not converge. So you can use parentheses. You only need to test the endpoints when we're doing the ratio or root test for power series. So that's our interval of convergence. We still have to simplify our power series because it's not simplified yet. First thing we'll do is we will, what will we do first? I'll distribute the n, the exponent. So I have negative x to the 3n over 2 to the n. So I can write it like that. And then now I can bring the x squared inside the summation. So I have n equals 0 to infinity. This is negative actually, there's one more thing I need to do before I bring it inside. Because right now, the x's, they're not the same. So x squared is a positive x, and negative x to the 3, and it has a negative x. So I will actually write it as negative 1 to the 3n times x to the 3. And I'll have to do that first before I bring it inside. Okay, now I'll bring it inside. Negative 1 to the 3n, and then x to the, so now it's going to be 3n plus 2 over 2 to the n. Okay, so there you go. This is good because we only have one x variable now. So this is your simplified power series, and then this is the interval of convergence. All right, so let's just recap everything. Where did the plus 2 come from? So I'm combining x to the 3n with x squared. So it's x to the 3n times x squared. So you add the exponent. All right, so to recap everything, to write it as a power series, we got it into this form. So 1 over 1 minus some function. And then once we have it in that form, we substitute it with the power series, provided that the function is less than 1. So this gives us the interval of convergence. And then we can just simplify this part to have one x variable. Okay. So do memorize this. Actually, you don't even need to memorize. You can just look it up when the question comes. Every quiz or every test is like an open book test now, so it's whatever. All right, you guys good on that? All right, Q5. Approximate the following function with a Taylor polynomial of degree 6 with center 0. Okay, so first of all, do you guys remember the notation we use for Taylor polynomial with degree 6? Do you guys remember how we denote that? So T sub 6 of X. So remember that a Taylor series is all of the terms in the series, but a Taylor polynomial of degree 6 just means list out the terms in the Taylor series until you get to the term that has a degree of 6. So that's not all the terms, that's just some of the terms, right? So these questions have two approaches, and you'll need to decide which one to use. So the first approach is when you're given a function that has a part that's inside the table, the popular Taylor series table. So when you're given a problem like that, there's one approach to doing the problem. And then there's another kind of problem where you're given a function that's not in the table. So first we need to identify whether or not this function is in the particular table. So let me just pull up the table. It is in a table. Okay. Let me just find it. All right, I can't actually. I'm like it logged me off of my Gmail. So can you just tell me what the Taylor series for the one in the table is? Summation. Yep. I'm assuming such as 0 to infinity. And then what's the summation like part? Is it just x to the n? Yeah. Okay. 1 plus x squared plus x to the third plus, okay. And then what's the corresponding function for this Taylor series? Wait, this is just the other one, isn't it? This is just the one we just used for the other question. It's 1 minus x, right? Okay, so yeah. This Taylor series will apply for this question because if you look at our function for this question, this is just basically x times 1 over 1 minus x, right? So because we already know the Taylor series for 1 over 1 minus x, which is the series right here, we can just use substitution. So this is x times this Taylor series. You can either just write the summation notation, or you can write out like the series notation. So 1 plus x squared plus dot 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 dot, and then this is going to be x plus x to the second power plus x cubed plus x to the fourth plus on and on. Okay, so that's our Taylor series for this function, but we don't need to list out all the terms because the question only wants us to list out t sub 6. So what is t sub 6? T sub 6 is actually going to be the first how many terms? Yeah, 6 terms. X to the 5th plus x to the 6th. Okay, great. So that is our answer for Taylor polynomial of degree 6 with center 0. Oh yeah, one more thing. So the reason why we were able to use this formula in the table is because this question also specifies center 0. So that table that I showed you guys, though all those series in the table are also with center 0. So make sure your question also says center 0 when you're using the table. Okay. Center was A, will we just write x minus A? Yeah, I guess so. But a question will usually specify what A is. They won't just say x, like the center is A. Because it's 6 terms including x in the beginning. Wait, never mind. Huh? What? What? Okay. What do you do if the center isn't 0? If the center is not 0, then you'll have to do it the other way, which I think you'll see what the other way is in the next question. Let me see what the next question is. No, never mind. It's also center 0. Actually, no, it's fine. The next question, you'll get to see what you need to do if you can't use a table. But yeah, are you guys okay with this one for now? I'll answer your question in the next example. Okay, question number 6. So this one says approximate the following function with the Taylor polynomial of degree 2 with center 0. So yeah, but the way we're going to do this question will apply to questions that even if the center was not 0, like this method will still apply. So first, notice how this function, -3 to the x, that doesn't relate to any of the functions given in the table, right? So because of that, you will not be able to do this question like the one we just did. We will have to use the, I guess, like the more, the long method, basically, the method that works for any problem. The previous method was like a shortcut to these problems. So what is the long method? Well, the long method requires you to first recall the Taylor series formula. So let's pull that up. So here is the Taylor series formula. So first thing we'll do is we'll just plug in the center because they gave it to us. So f of x is equal to summation of n equals 0 to infinity of f nth derivative of the center, which is 0, over n factorial over x minus 0 to the n. Okay, so the thing we need to find for the formula is this part right here. So the f to the nth of 0, that's the part we need to figure out. And the way we figure that out is we need to take derivatives. So let's go ahead and do that. So the function is negative 3 over x. If we evaluate this function at the center for 0, we get undefined. That's fine. Let's find the first derivative. So what's the first derivative? This is technically negative 3x to the negative 1, right? So the derivative would be 3x to the negative 2. Okay, and then let's find the second derivative. That would be negative 6x to the negative 3. Okay, let's evaluate all these derivatives at the center 0. So f prime of 0, f double prime of 0. It's still undefined, isn't it? Yeah, this is weird. I think I messed up this question. Okay, well, all right, yeah, that's not supposed to happen. I think what I meant to do was make the center another number. So I'm gonna just change this to negative 1 just so we can see how this question finishes. So imagine if the center was negative 1. Actually, let's make it something easier. Let's make it 1. So imagine if the center was 1, and then let's recalculate these derivatives. Yeah, I'm not going to give you one where it turns out to be undefined, because then you can't write the Taylor series. So if we evaluate this at 1, we will have negative 3. This one will be positive 3. And this one will be negative 6, right? Okay, so we have some values. Now let's try to start writing out our Taylor series. So the first term in our Taylor series is when n equals 0. So when n equals 0, we will have the following term in our Taylor series. We will have, so looking over here, wait, why do we stop with the second derivative? It's because, well, honestly, I'm not sure what derivative we need, but since this says degree 2, we will probably only need the second derivative. You'll definitely see how many derivatives we need once you write out the terms. But for n equals 0, we're going to have the following term. We're going to have f of 0 of negative, well, yeah, I changed the center, so the center is no longer 0. So this is supposed to be 1 now. X minus 1. Okay, so this will be over 0 factorial times x minus 1 to the 0th power. And then we have the next term and the next term after that. Hopefully that should be enough. Plus f1 of 1. Sorry, this is positive 1. factorial x minus 1 to the first power plus f, the second derivative of the center, 2 factorial x minus 2 to the second power. Okay. Yeah, I feel like this should be enough because notice how we have x minus 2 to the second power. So that's already degree 2. So this should be enough. Okay, so f of 0 of 1, that's basically the 0th derivative evaluated at 1, which was -3. So we just have -3. 0 factorial is 1, and adding to the 0 power is 1. Okay, so plus f of f to the first derivative of 1, that's 3, over 1 factorial, and then x minus 1, plus the next one, which was -6 over 2 factorial, that's 2, x minus 2 squared. Okay, all right, so there you go. This is the Taylor polynomial up to degree 2. Yeah. So hopefully you guys can see that for this method, doesn't really matter what's up, x minus 2 squared at the end. What's up? Did I miss something? Then x minus 1. Oh, yeah. Yeah, it gets confusing with all these like indices and centers. You sort of lose track of what's what. Yeah, but what was I going to say? I hope you can see that with this method, it doesn't really change when you change your center. So for example, if the center was 2, this method wouldn't really change. You would just, change your values here, right? And then that would just change your coefficient. That would change this number, that would change this number. But the method is still the same regardless of what center you're given. Obviously, I'm not going to give you one that makes it undefined, but you can see that this method is universal. So you can use this you could use this method for the previous problem as well. It's just that you didn't need to because we know the power series, or we know the Taylor series for that particular problem. All right. Yeah, any questions? I think that was the last one. Yeah, that was the last one. So any questions from 1 through 6 on this review sheet? Do we need to know how to generalize the nth derivative of a function? Yeah, so I was going to get to that. But yeah, if you look at the review sheet, on the bottom, I made a note that says the extra credit problem you will have to derive a Taylor series for a given function. So for that type of problem, yes, you'll need to know how to generalize the nth derivative of a function. Can you break down how you solved it at the end? Could you be a little more specific? Which part are you talking about? Like the f to 0th power of 1 over 0 factorial. Okay, so this part, right? So we're trying to write out the Taylor series. This is the formula for all the terms in a Taylor series. But we don't have to write out all the terms. We just need to write out terms until we get to the one with the second degree. So the first term in the Taylor series is when n equals 0. So this is going to give us f of 0 of 1 over 0 factorial over x minus 1 to the 0 power. Are you okay with that part? Okay, so f to the 0 of 1, what that notation means is the function to the 0th derivative of 1, which basically just means evaluate the function at 1. So we did that. That gave us -3. So we get -3 here. This is -3. 0 factorial is 1, and then anything to the 0 power is also 1. So the first term in our Taylor series is just -3. Yeah, okay. And then if you want to, explain this completely, so the next term in our Taylor series is when n equals 1. So then you get this term, which, turns out to be this. So yeah. Okay. All right, let me just make a comment on the extra credit. So the extra credit problem on exam 3 will just be asking you to derive a Taylor series for a function. So we did do one question like that on the lecture, which was, I think, like 1 over x squared or something. It was like the first example. But that's the question where you have to write out a lot of derivatives and then see what the pattern is for the derivatives. So, find the formula for the nth derivative, which you will need for writing the Taylor series, because that's basically this part. But yeah, I think I emailed you guys some resources, right? So in my previous email, I gave you a video, which teaches you Taylor series, but also a link to like a website that has some examples of the person working through how to derive the Taylor series. Can you show us how to do it for this function? I mean, yeah, I could try. I'm not sure if it'll work out nicely though, but yeah, let's try. So, because we have a little bit of time. So if you kept taking the derivative here, let's see what you would get. So f, and then the third derivative. When you're trying to find the general derivative, it's better to not simplify each part. So let me just move this here. Let's give myself more space. Let me also rewrite this. So this was -2 times 3, x to the -3. And also let me rewrite this as -3 x to the -1. So then the next derivative would be, let me also rewrite this. So the way we got the first derivative was we brought the exponent to the front, and then we multiplied by -3, and then x to the -2. Then to get the next derivative, we brought the exponent to the front again. So that was -3, -1, -2. So then the next one will be -3, -2 times -1 times -3 x to the -4. So are you following so far? I'm finding the derivatives, but I'm not really like simplifying my derivative. And then I think from this, you can sort of see the pattern. So f to the nth of x would just be, So it would be, let's see, how can I write this? So the first derivative, or the first one is negative, the next one is positive, then it's negative, then it's positive. So it would be -1 to the n plus 1. I think that makes the first derivative positive. Let me also write out what n is for each step. So here's when n equals 0. Here's when n equals 1. Here's when n equals 2. And here's when n equals 3. Okay, and then there, you can see how there's a factorial forming here. So that's basically n factorial. And then you have -3 x to the negative n plus 1. Yeah, so that would be the general form of your derivative. Three, yeah, I don't think you have that right. Let me just write this part a little more clearly. So there was a -1 here, and then there was a -2. So as you take more derivatives, the exponents sort of stack towards the coefficient of the expression, which forms a factorial. And this part was just to accommodate the alternating signs for the derivatives. And then this is the factorial part. And notice how each derivative also has this part, right? So that's a -3x to the negative some power, which also goes up. So that's this part here. So this would be your general form of your derivative. And then what you would do is you would evaluate your derivative at the center. So in this question, I said the center is 1. So f of n of 1 is just -1 to the n plus 1 over n factorial. -3 negative positive 1. So there's I plug in the x, negative n plus 1. So then this would be what you would plug in into your Taylor series. So a Taylor series formula is over here. So that's the Taylor series formula. So then your Taylor series would be this part divided by n factorial x minus a to the n. So that would be the whole Taylor series. This would be the answer to the, if this was the extra credit problem. Which, I wouldn't ask you to derive on a regular problem, but you could actually use this to do this problem as well. So for question number 6, instead of doing it like how we normally do, you could actually find the Taylor series and then just write out each term of this Taylor series. So write out, the first term, which would give you the answer we had before. But yeah, that's basically how you would do it. You would just observe the pattern for the derivative. All right. Any other questions? Okay, so if there are no questions, then we'll stop here. So the exam is on, exam number 3 is on November 8th, regular class time. The final exam is December 15th from 5:20 to 7:20. And then, yeah, I believe this is the last time we are having a lecture. So I guess we'll make the obligatory speech now. Yeah, that's the day of the last final, the final exam. All right, so let's see, what can I say for this? It has been a pleasure, y'all. So I hope you guys learned something from this class. I know a lot of you are going to take a lot more classes in the future. Yeah, what's up? This is the last class. It's the last lecture because the next time we're just having exam number 3, and then after that is the final exam. So I'm never going to talk to you guys again. What class are you teaching next semester? Oh yeah, I forgot to tell you that. So the person who gives out the classes for Hunter, she got back to me and she said that I don't have a class next semester. So unfortunately, I'm not teaching next semester. They said that it's because they've taken a really big budget cut. So they had to lay off a lot of adjuncts, which, you know, I understand, you know, like they have to cater to their full-time faculty. They have to give them classes before they give people like me classes. So I don't have a class to teach next semester, but yeah, it's fine. I mean, I'm sure there's other great professors you can take whatever calculus 3, you know, for, so it should be fine. But yeah, I mean, I hope you guys, you know, learned something. If you didn't learn math, I hope you guys at least learn how to like solve problems. And yeah. I know a lot of you guys have grown as a student, so that's good. Rate my professor. You know, I don't actually have, how do you even get a rate my professor? I don't even know. Last Cal teacher told me nothing. You didn't agree.
Honestly, I think it's like the college who puts you up there. So
Okay,
you gotta
yeah.
like ask them.
All right, well, I'm not asking them because I really don't care. But
Chad, absolute mad lad. Respect, man, respect.
But yeah, so that's all. I'll see you guys for exam number 3.
Oh, I have a question. There's going to be a final after exam 3, right? Or is exam 3 the final?
It's 2 separate things. So
2 separate. Okay.
Yeah, there's a final after exam 3.
What date would that be?
December 15th.
15th. Okay, hold on. Let me write that
From
down.
5:20 to 7:20.
From 5:20 to 7:20.
Yeah, so it's like a little bit earlier than regular class time. But
December, you said 7? Hold on, no. 17? 15. Okay.
Yeah. There's no class on the 10th because December 8th is the last day of classes. So you know we don't meet anymore for class after that.
Right.
I never saw my professor's face from calculus last semester. What? Okay, that's funny. Yeah. All right. So that's all.
Thank you.
Yep. The final is, for those of you who have no questions, you can leave, by the way. So the final is going to be the same format as the exams. There's probably going to be a little more questions. So the exams were around like 6 questions. So I'm gonna put a little more questions, probably like 8 or 9 questions on the final. But the format is the same. So it's like one of the questions is dropped, and then I'll grade you based on the other ones. And there's extra credit. But yeah, same format for the final.
Will you be doing curves?
Oh yeah. So during finals week, so before our final, I'll just post some videos on Blackboard about me lecturing like chapter 9 stuff. Because you need it, right?
Professor, will there be a curve? Because a lot of professors
Oh,
that I have are.
I misunderstood. I thought you meant
Oh.
curves as in like the chapter 9 stuff, because chapter 9 is about curves.
Oh. Oh, okay. Okay.
No, okay.
I mean, I guess that could be useful, yeah, just to have that content. But yeah, so that would be appreciated. But in terms of like, will you be curving our grade? Because a lot of my professors are kind of iffy about it since everything is online now.
Yeah, I don't even know if I'm allowed to. I don't think I need to though, because everyone's doing fine. So I don't see a need, but like if I need to for some whatever reason, I'll definitely have to like ask for permission from the department. But
All right.
yeah.
All right. Well, thank you so much.
Yeah,
Have
no
an
problem.
amazing weekend.
Yep.
See you on the day of the test.
Yep. See you.